So hello friends. So in this video we will see the structure of lactose. So in the past two videos நீங்க எல்லாரும் பார்த்திருப்பீங்க. நம்ம disaccharides ஓட structure பத்தி discuss பண்ணோம். We studied the structure of sucrose that was followed by maltose, and now we are going to see lactose is a sugar which is present in milk. So all of us know it is present in 4% of the content in the cow's milk, and it is present to the extent of 6 to 8% in the base of mother's human milk. Okay, so this lactose, what is the structure and the properties of this lactose? So the first one is, as usual, from the elemental analysis, this was again known to have the same formula C12H22O11 as the case of your sucrose and also the maltose. And the second point is lactose on hydrolysis gave two monosaccharides again. So on hydrolysis gave two monosaccharides, namely glucose and galactose. Glucose and galactose. So glucose and galactose are the two monosaccharides that is present. And so we can understand that disaccharide made out of glucose and galactose unit is lactose. So next, as usual, we need to find out whether it has a reducing or non-reducing end. So it is found to reduce failing solution, reduces failings, tolerance, reagent, and it also exhibits mutarotation and shows alpha and beta forms with characteristic specific rotation, and it exhibits mutarotation. So all these points confirm that this lactose is having a open or a free carbonyl end. It has a free carbonyl end. So all these above points conclude that there is a free carbonyl end. Free carbonyl end. And once again, from the osazole that is formed, we can understand that the free carbonyl, there is only one carbonyl, free carbonyl end from the osazole. Osazone that is formed, we can understand that only one free carbonyl end. Okay, so just we would understand that the structure should be more or less similar to that of maltose, and now we need to know, we know that the monomers that are involved are glucose and galactose. So we need to know whether the glucose is alpha or beta, or the galactose is alpha or beta. So what we need to know, we need to do the enzyme specific analysis. So the lactose is being hydrolyzed by an enzyme lactase, so which is characteristic of beta glycosidic linkage. So this lactase hydrolyzes all the beta glycosidic linkages. So there should be, we understand that from all these, we understand that there should be a 1,4 beta glycosidic linkage. So with all these, we can assume we can confirm the structure of lactose to be. Okay, so for this, we need to write down, as usual, we need to write down because it is a beta sugar, we need to write down the beta sugar. So beta sugar, I should put OH at the left side, H in the right. As usual, as and when I write, you also write, please. Okay, take your notebook and just keep writing. Otherwise, you will not have all this in mind. Right. So this is my glucose. I know very well. Then I need to put the hydrogen here, and this is my what glucose? Beta glucose. This beta glucose is going to react with the galactose. So what is the structure of this galactose? Galactose is nothing but just the fourth carbon is going to be an epimer. Galactose is an epimer of glucose. So in the epimer na enna edho or carbon sutti HOH position marinda adi epimer, right? So see, this is also in the beta form. So I'm going to write HOH, right? Everything else is going to be the same except the fourth carbon. Fourth carbon la mattu enna pannanum in the HOH edam maaranum. So this is first, second, third and fourth. So in the edathila mattum da edam maarum, meedi ellame the same. Okay, yes, HOH, and in the carbon la da edam maarapodhu. So once again HOH, H and OH, right? CH2OH, right? So we have written the beta galactose form, right? So beta galactose and glucose are going to link via what fashion? 1,4 linkage. So what I should do now? I should take this. So what is going to adjust? I will write and show you. So what is happening here? This OH is going to condense with this one, and they are going to be removed as water outside. So what I will do now, I will. So what will happen now? My linkage will be. So when the water remove aachina, and the glycosidic linkage, and I probably calm. Okay, let me put it in green, red. So I will be having a glycosidic linkage like this, right? So this is what is called as a beta 1,4 glycosidic linkage. Beta 1,4 glycosidic linkage. So you need to understand that this galactose is in the right hand side. Galactose order 1 position, glucose order 4th position match. They are linked with each other. Okay, so this is the structure of lactose. Okay, yes. So we will end the YouTube. So once again, I would like to tell you the molecular formula is C12H2211, and that on hydrolysis, lactose gives glucose and galactose. So we understand that the two monomers that are involved are glucose and galactose. Then, as usual, like maltose, it reduces the Fehling's tolerance. It exhibits alpha and beta form. It exhibits mutarotation, and it forms alpha methyl glucosides. From all these things, we understand that the lactose contains a free carbonyl group, and from the osazone, we can understand that there is only one free carbonyl group. Other one is involved in linkage, so there should be a 1,4 linkage. And இப்போ வந்து ஆல்ஃபா குளுக்கோஸா இருக்கா பீட்டா குளுக்கோஸா இருக்கா ஆல்ஃபா கேலக்டோஸா இருக்கா பீட்டாவா இருக்கா அப்படின்னு கண்டுபிடிக்கிறதுக்காக we are using enzyme, and by using the enzyme we understand it's both are in beta. So if it is in beta, then you have to draw the structure similar to that, and you are drawing a glucose and a galactose. Galactose differs in the configuration around the fourth carbon. So HOH ன்னு குளுக்கோஸ்ல இருக்கும், இதுல OH H ன்னு இருக்கும். அது ஒண்ணுதான் டிஃபரன்ஸ். மற்றபடிக்கு குளுக்கோஸ்க்கும் கேலக்டோஸ்க்கும் there are no other difference. So these two sugars are linked via 1,4 linkage as is represented here. So as is represented here, so you can understand this is a 1,4 linkage, right? So this is what is a lactose structure. We will stop now, and the next lecture we will see the Haworth formula for all these disaccharides.